Good morning, folks. So we have used this function-based calculator when we were learning our while loop and for loop. Let's refactor this code. Let's refactor this old logic by including the clean and reusable functions. So we are going to add for each and every operations into a separate DEF function and one function to handle an input, and function composition I'm going to add if it's needed, like I can add the history loggers, validations. Now let's go back to this calculator example. What we had done, let's write this code for addition. For add a comma b, return a plus b. For subtract a comma b, a minus b. Right? So similarly for addition, subtraction, multiplication, division, power, modulus, and to get the input, enter in two numbers separated by space. So I'm going to pass the input as well. Right? So this is going to be in separate function. Then I'm going to have a menu based loop. So what will this menu based loop have? I'm going to have for the calculator menu, 1 is for addition, 2 is for subtraction, 3 is for multiplication, 4 is division, power, modulus, and 7 is for exit. So I'm going to take the choice as an input. Right, so the moment I take input, it will be string. I am giving a choice if it matches 7, if it matches a string. Thank you for choosing the calculator. Right? It's going to use this break and it's going to come out of this loop. It's going to get inputs a comma b, two inputs. Right, so get inputs. Right, so two inputs. It's going to be it's going to receive. Comma. Right, so since I've used this split, then it's going to take it as a and b. Right, so if it's 1, then addition, 2 is subtraction, 3 is multiplication, division, power, and modulus. Right, so if it is an addition, right, so I'm going to pass two numbers, 12 comma 10, 12 space 10. Right, so and then for subtraction, 12 space 10, 21 space 10, and it's 11. Right, so and let's give it as multiplication. Now let's give 2 space 5. Right, so the result is 10. Right, so it's going to take the response like that. Right, so what did we do here? So we have our own functions that's been inculcated here for all this logic. Right, so and we have built this with a while loop. Unless and until I give 7, it's not going to come out. Thank you for using calculator. We have used this break. Right, so this is a fantastic example where you can see that we have updated this using this modular structure. I've added all this functions here, and we have focused on the function design and the reusability. Now we have refactored to improve the code structure. Right, so now we have learned the function parameters, return values, modular code structure, how to call one function from another. Right, so we have one function, how to call one function from another function, that you have learned. Right, so these are important things that you have learned here. And yes, now I want to slightly change this. I'm going to say it as modular function-based calculator. I'm going to bring in a modular function-based calculator here. Right, so now I'm going to define all the operation functions like how we have defined for addition, a plus b, subtraction, multiplication, division. Right, so all these functions I'm defining it. Alright, now I'm going to handle inputs using this map. Right, so enter two numbers separated by space. I'm going to use this map function. Look at this, the float. I'm going to use the split and I'm going to store it in a comma b, and it's going to return a and b. Now what's the beauty here is I'm adding an exception. Right, if it is not a valid number, I have a try except block, the exceptional handling. Right, so now it may not throw an error here. Now this will throw an error here. I'm handling it in a better way. Now let's have this calculator handler menu. Right, so I have this menu. One is addition, subtraction. So what do we want to enter? Now let's build this main orchestration function. Right, so how will I build this orchestration function? Let's use DEF calculator. Right, so history, open close bracket. Right, so to store all the operation history. Right, so while true, I'll say show menu and I'll give the choice input, right? Choose an option from 1 to 8. choose an option from 1 to 8. Right? So now I will say if choice is equal to in string 8, because I have not made int of input, rather I have made input of this. Therefore this will be in string. Right? Now I'll use print thank you for using the calculator. This is the exit statement, right? So I want to break this. I'll use break. Now I will say else if choice is equal to 7. If the choice is 7, now let's print all the previous calculations to be displayed. Right? So for an entry in history, print the entry. Right? Now I'll use the continue. Right? So if choice not in, right? So look at this carefully. Not in 1, 2, 3, 4, 5, 6. Right? So if it is not in 1, 2, 3, 4, 5, 6, I'm going to print invalid choice. Right? So invalid choice. Try again. Right? So I'm making it more robust now. Continue. Right? Now I'm going to get two inputs. A comma B is equal to get inputs. Right? So get inputs. If at all the choice is equal to 1. Right? So then I'll have this result is equal to add A comma B. Right? So the operation is addition. Right? So else if choice is equal to 2, then the result is equal to subtract A comma B, then the operation is equal to minus. Else if the choice is double equal to 3, the result is equal to multiply A comma B, the operation is equal to star. Right? So else if choice is double equal to 4, then the result is equal to divide A comma B. So the operation is going to be in division. Right? So similarly else if choice is equal to 5, and then put the result as power A comma B. So operation is equal to mod. Right? So I'm sorry, this is power, right? Then 6, else if choice is equal to 6, then the result is equal to modulus A comma B. So the operation is equal to %. Now let's print with an F string result A op. What is the operation? B is equal to result. We have the result that's stored. Correct? Now whatever that we have printed here, I would like to store it in the history. History dot append F string A operation B is equal to result. Right? So that's what we are placing it here. So with an F string literal, the result A op B is equal to result. Right? So A op B, I'm going to store it in the result. Now let's run this. Now let's call this calculator. I want to add 10 comma 10 space 20. Okay, it's 30. Now I want to view in history 7. Right? So the previous calculation 10 plus 20 is 30. Now let's do the subtraction. Let's do everything at once. And multiplication 2 comma 2 space 3, and division 1 space 2. Okay, and then power 9 space 2, and modulus 3 space 2, and then 7. Now let's see what do we have here. Right? So all the previous calculations I have stored it. 10 plus 20, 20 minus 10, 2. So still the from the beginning of this the function call, all the calculations are stored. Right? So now I'm given the capacities to store, and then I'm exiting it. Right? So what did we do here? I've created this function as usual. We've got the input. I've put the exceptional handling here, and in the show menu I've given all the menu here. So here we have handled it in a more robust way. Right? So if the choice is 8, and for all the 7, if I'm going to give 7, all the previous calculations are going to be stored in history. Right? So this makes your calculator more robust. Right? So as a takeaway, as an takeaway, you can add and square root and factorial functions. You can accept multiple numbers using args and the map function, right? So whatever the error that you see, you can add to a log file, right? So, and you can add and text the test model test calculator, right? So, and I'll say it as additional challenge. You can add square root and factorial functions. I can accept multiple numbers using args and map. I can add error logging to a file, right? So I'll call this as an log.txt file, right? So then I can add a unit test module, right? So test calculator.py, right? So I've added the test square root, so you can add and square root and factorial functions to it. You can accept multiple numbers using the args, right? So this args and the map, right? So, and you can add an error handling log to use this log file, log.txt, and text calculator you can add and test unit test module, right? So this makes your calculator code even more robust. We have given 2-3 examples to make sure that you understand all the functionalities that's using this the DEF and the lambda functions, all the built-in the functions map, filter, length, sorted, right? So, and in forthcoming session we'll start with Python for data science, how to install and import libraries, what is NumPy, right? So why is NumPy array used for creation, indexing, basic math, other than using various other libraries? Why are we preferring NumPy and why are we using pandas data frame, right? So, and after that we'll have a project. Thank you.